Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Cyclohex-1Na reacts with a peracid, RCO3H, to form cyclohexene oxide 1,2-epoxycyclohexane. The oxygen is delivered in a SYN, CIS, fashion to the double bond, giving a CIS epoxide. Moving on to the next step. The Grignard reagent, CH3NGBr, opens the epoxide via an SN2 mechanism. SN2 attack proceeds with inversion at the carbon being attacked. Since the epoxide is symmetrical, cyclohexene oxide, the methyl nucleophile attacks one carbon from the back face, resulting in inversion at that carbon. The oxygen and the incoming methyl group end up trans to each other, anti-addition overall. And for the final step, the alkoxide intermediate is protonated to give the alcohol. Overall stereochemical outcome, the epoxide oxygen and the CH3 group are introduced with net anti-addition across the original double bond. This gives a trans relationship between the O and CH3 groups on the cyclohexane ring, i.e., trans 2-methylcyclohexane 1-ol. The product shown in option B depicts O on a dashed bond and CH3 on a wedge bond at adjacent carbons, representing a trans, diaxial diequatorial relationship, the trans isomer. Why other options fail? Option A shows a CIS relationship, both substituents on the same face, which would result from retention, not inversion, incorrect for SN2 epoxide opening. Option C shows a diol on a cyclohexene ring, which would be the product of OSO4 dihydroxylthione, not the given sequence. Option D shows 1-methylcyclohex-2Na, a simple alkene with no oxygen functionality, which does not account for the epoxide opening. Therefore, the correct answer is B. Therefore, the correct answer is option B.